This question is taken from the ENGAA 2020 Section 2 paper, and it is question 17. So we read, water in a river flows at constant speed, 0.5 meters per second. A swimmer goes around a square path of side 30 meters, marked as shown. The swimmer has constant speed of 1 meter per second relative to the water. This is a diagram for the square path and the speed of the water going from left to right. How long does it take the swimmer to swim around the square path once? So they mentioned that the swimmer has a constant speed of 1 meter per second relative to the water. So in the water's frame, he'll always be moving at 1 meter per second in any given direction. So in the first part of the journey, he'll be moving from right to left. And then from R to S, he will have to move in a northwesterly direction so that the water, when it takes him from left to right, his resultant velocity is just directly upwards. And then from S to T, he'll be going in the same direction as the water. Then from T to U, he'll be moving in a southwesterly direction so that the water takes him back along here, and his resultant velocity is directly downwards. So if we look at his velocity in the water's frame, this is what it should look like. So this is the first part of the journey, then the next part, then the third part, and then the last part. So then in our frame, once we've added the water velocity vector back, so seeing how fast he's actually travelling in our frame, we have 0.5 meters per second as a resultant velocity from U to R. So this is the 1 meter per second from right to left. Take away that 0.5 from left to right of the water. Then from R to S, he's moving at an angle of with 1 meter per second velocity, and then the water is trying to take him back onto this path so that his resultant velocity is just directly upwards. This is square root of 3 over 2 from Pythagoras. So square root of 1 squared minus a quarter is square root of 3/4 here. Then the next part is also quite simple to calculate. So we have 1 meter per second add 0.5. Now, because they're travelling in the same direction, we have 1.5 resultant. And then from T to U, in a similar way to RS, he's now moving southwesterly, so that the water takes him back in this direction, so that he's moving directly downwards overall. So we want to get the time taken for him to swim around the square path once. So we just need the distance over the velocity in each example. So we have 30 over 0.5 plus 2 times 30 over the speed in RS and TTU, and then 30 over 1.5 where he was travelling fastest. So doing these calculations, we get 60 from 30 over 0.5, then 40 root 3. So this was 4 times 30, but then one of the root 3's comes out. So we got 40 root 3, and then we get to 20 here. So if we add all these together, what is our answer? It is 80 plus 40 root 3 seconds. So this is how long it takes him to travel all around the square path once.